Hi everybody, my name is Niloufar Sarraf. I am very excited to be making this presentation for you guys. If you have any questions, please feel free to reach out to me at any point in time via email or any other means that's possible. But for the purpose of this presentation, I'm going to talk about my doctoral dissertation where I'm trying to position myself in the field of neuroinformation science. And before I start, I just wanted to share with you a few disclaimers. One being that this is in regards to my in progress dissertation, meaning to say that there is still a lot to be done. There are many questions that I still do not have the answers to. Also, this I wanted to bring to your attention that by no means I'm a neuroscientist. The little background I have in regards to neuroscience pertains to the research I did at Stanford University. But I just want to really make sure that you guys understand that I'm not a neuroscientist. I will be talking about some parts of the brain, but it's not from the neuroscience perspective. My background is in human-computer interaction. Also, this work is not affiliated with the company that I work with at the moment. Also, a little bit of a background about myself. I started my research career as a research assistant at Stanford University in California, where I worked at a neuroscience lab with Dr. Knudsen. I had probably the best time of my life working at that lab. It was very exciting working with neuroscience related um, studies where we used the fMRI machines. I helped Dr. Knudsen with a lot of the data analysis, and it was really fun. At the same time, I was also pursuing my bachelor's in cognitive psychology and statistics, and then after which I continued pursuing my master's in human-computer interaction, and that's the first time I got introduced to research, conducting research in the industry, where I got a internship at Yahoo, and I've been working in the industry since then. For the moment, while I'm working full-time in the industry still, I'm working on the writing my dissertation, and I'm positioning myself in the new field of neuroinformation science. I'm also very interested in anything about wearable computing as well as artificial neural networks. And for the purpose of this lecture, I have divided this presentation into two distinct parts. In the first part, I will be talking about my in-progress dissertation, how I'm positioning myself in the neuroinformation science. Also, I'll be talking more about the exact title of my dissertation, which is in regards to the impact of different dimensions of emotions on search performance. On the second part, I'll be talking about some of the proposals that I have to the industry. A lot of these are still at the theoretical level, but I'll be talking about how you can actually get the results of this dissertation and making something practical with it in the industry and coming up with some solutions, more specifically in regards to artificial neural networks, architecture solutions, as well as search engine solutions. And I'll be talking a little bit about that. So for the first part, let's just have an overview of the dissertation. The purpose of the dissertation is to examine any potential effects of different dimensions of emotion on information retrieval, more specifically when it comes to web search performance and web search processes for the purpose of my study. I am focusing very narrowly on examining the effects of different emotions and different dimensions of emotion on search performance, for example, search effectiveness and search efficiency. And my aim is to draw a conclusion, if any, to be able to say that specific dimensions of emotions have or do not have impact on search performance. Um, Also, a little bit of a background in regards to affect in design. Definitely, the affective component of information retrieval system in design are becoming increasingly essential. For example, Noll and Bilal already in 2007 introduce expressions such as pleasurable engineering or emotional design. And we also see it in the industry more and more that the awareness about using these different emotions when you design solutions in the industry, that is becoming increasingly important. And the least that is happening right now that I see is that people in the industry are at least talking about it, which I think is fantastic, because just a few years back, if you mentioned this part of the important component in information design, there was not much of a, I guess, welcoming attitudes from the industry, whereas now people are actually excited about it and actually talking about it. Also, the history of information science research is very important. If you go back and look at research that was done a few decades ago, 2 decades ago, it's very, very apparent that a lot of these research in regards to information science, they are actually more geared towards system-oriented approach. They talk a lot about precision and recall, and in a lot of these studies that you read, humans are not really involved. It's more about the system, that how the system is actually retrieving that information, which is very interesting, because whenever you have a machine, you also have a user, but in none of these studies you actually um, bump into any user within this study, which I find it very fascinating. And then after that, you clearly see that there's an evolution in terms of the type of studies that are being done, whereas these type of approaches become a little bit more user oriented. These type of research papers, they start addressing more user behavior and talking about a little bit more about users interaction with the system, with the information retrieval systems, which it's very exciting to see, because then it seems like researchers have come into thinking about, okay, there is actually a user involved. Then after that, it's also interesting to see the evolution of these information science type of studies then be geared more towards the cognitive processes of users. So it's not only about the behavior now, but it's all about more about cognitive processes, where they're actually thinking about how the brain works and what are the maybe the some cognitive models that are involved, if you will. And last but not least, very recently, just over the past few years, we're now seeing more studies that are geared more towards the affect or emotion part of human beings. And to me, this is a very um, logical, I guess, part of the evolution, if you will, because whether we like it or not, humans are um, not only logical but filled with emotion. So if you do not take into account the different dimensions of emotion in these studies and thinking about industry, thinking about design solutions, I think we're really missing a big piece of the puzzle. And I'm very excited to see that these type of studies are actually evolving and sort of blooming more, if you will. And my study is aimed also to add to the body of knowledge within this realm of the research. Also, talking about specific research questions I have, there's definitely a gap in examining the effects of physiological and neurophysiological uh, responses when it comes to web search performance. There are a lot of studies where these are being examined, but more from a behavioral perspective. A few studies are, for example, talking about the neurophysiological aspect of it or physiological aspect of it. And that's where my study will fill this gap, if you will. For the purpose of my study, I've conducted already 2 dry runs and 2 pilot studies. I've also collected all the data for my main study. And some of the questions that I'm trying to uh, find the answer to from the physiological as well as the neurophysiological perspective is how do these dimensions of emotions impact search effectiveness, search efficiency, and whether there is an interaction between the two. And my hypothesis is that when it comes to the positive dimensions of emotions, they have positive impact on information retrieval. In other words, they have a positive impact on search effectiveness and search efficiency. Now, let's have a quick review in regards to human emotions, because it is interesting to have an overview on that so that we gain a little bit more understanding as to how these different dimensions, if you will be used in the industry and hopefully in a lot of future research as well. I'm sure you guys already know this, the famous Kuhlthauer's model of information seeking processing model, or the ISP model, definitely is one of the first theoretical models that has strived to include different emotions within different steps of information seeking. I'm sure you guys all know these stages. She talks about initiation, selection, exploration, formulation, collection, and presentation, which very I think interestingly, these models still hold. I believe I read a few studies a few months ago where they were actually trying to test whether this ISP model still holds, and they were able to test and say, okay, it still holds. So to me, that's very fascinating. Another model is Schrerer's CPM model, or emotion and information processing. This is also very, very interesting because Schrerer talks about not having very discrete emotions, but having these continuous emotions where you have different dimensions of emotion that I'll cover very, very shortly. And so as I said, Schrerer, for example, talks about continuous emotions, but there's also discrete emotions. So within the field of research, more specifically when it comes to research around emotions, there are 2 different disciplines, and the research community appears to not really settle down on exactly which one is more valid than the other, but that's usually the case. There one discipline that talks about emotion as being just discrete emotions, and then there's another discipline that calls emotions to be continuous. The discrete part of emotions goes back to Darwinian um, um, model, where they talk about that the human emotions are based on a few very basic emotions and nothing else exists. Paul Ekman, for example, one of the very famous psychologists who did extensive research around the world, and he eventually came up with 6 different discrete emotions. For example, fear, happiness, surprise, anger, sadness, and disgust. And basically, what this discipline is saying is that all human emotion consist of these 6 emotions, and that is what they are doing. Then, when it comes to the continuous emotions, they're talking about the different dimensions of emotions. And here's, for example, Russell or Schrerer. They're really talking about these different emotions. And what they're basically saying is that it's not only 6 emotions, but there's a continuous different type of dimensions of emotions, where they are talking about types of emotion being from valence to arousal. Valence talks about the positivity versus the negativity types of emotion, and arousal talks about whether a person is calm or excited. So if you think about it, a continuous emotion can really include a lot of different emotions. And here is a chart where you see the axis of positive versus negative, and then you see the axis aroused versus passive. And if you think about it, there's as you can see in this chart, they can really divide emotions into a lot of more emotions than just these six basic. And I've read books where at one point, I think I read a book a few years back where researchers have actually counted, I think, up to 4,000 different emotions for human beings, which is amazing. And basically these are the continuous emotion. And for the purpose of my study, I am focusing more on continuous emotions because I am looking at valence versus arousal, mainly because the neurophysiological techniques and data collection techniques are able more to are more able to look at the valence versus arousal, as opposed to saying exactly, okay, this person is, is in state of fear or something like that. It's more about these different axes, if you will. And now it's also interesting to look at emotional dimensions associated with brain waves. This field is still very in its infancy. So what you see here is essentially all there is. There is a lot more research to be done in this field, but a few research that has already been done, they've been able to connect alpha versus beta brain waves to different axes of arousal versus valence of different emotions. But still there's a lot to be done, but basically there are still some studies that indicate that, and that's why I'm using these studies for the purpose of my study. And also just to do a review about what these waves actually mean. The top chart shows the beta waves. You have 14 to 30 hertz of frequencies, where the beta is when a person finds him or herself in an active situation. They are maybe using body movements, or they're thinking a lot, or they're agitated, and that's when the brain frequency really increases. Whereas in alpha state, it's a lower frequency, and that's the second chart that you see. That is a state where it's more about a person who's calm. Perhaps that person has their eyes closed, or maybe they're meditating, or at least they're a little bit of a calmer state, so they are not as aroused. It's a little bit lower, if you will. And also, one of the techniques that I'm using is collecting EEG. And as you saw in the previous charts, I'm collecting beta and alpha waves. And this is the Neuro headset from Emotiv EPOC that I'll be using. There are 14 sensors here. It's a non-invasive device, and that's one of the main reasons I'm using it. So you don't have to stick anything into anybody's head. It's very non-invasive, but and it's also turns out to bring and collect really good data. Of course, there's always noise in the data, but there's ways to go around that a little bit. In terms of my research design, it's definitely an experimental research design. I'm using a two-way repeated measures ANOVA for statistic model. My independent variables are emotional states. For me to control them, I am using IAPS pictures of neutral, pleasant versus unpleasant. So I am controlling the emotions at 3 different levels. Also, alpha and beta waves are collected through the Neuro headset that you just saw. And I'm also using the SAM self-report, which it's a pictorial self-report that is supposed to collect data on the valence versus arousal of the participants. The dependent variable is search performance. I have collected data on time on task, task completion, number of search queries, and number of web pages. In terms of the web search task, this is very interesting because for a while I was really pondering a lot and thinking a lot about, okay, how am I going to actually distinguish between when the participant is actually conducting a web search and say, okay, here's where they conduct the web search and here's what's happening in their brain. And I was pondering on it a lot, doing a lot of reading until I one day bumped into White's paper where he has written, I think he dedicated big parts of his dissertation to actually come up with web search tasks that directly pertain to specific stages of ISP model. The specific stages of ISP model that he focused more on are exploration, formulation, and collection, mainly because when the participant is actually conducting that web search, that is what they do. So it's through the exploration, formulation, collection. So I was able to find specific web search tasks, the task type A, B, and C, going from high complexity all the way to low complexity, and they are, according to White, are supposed to actually pertain to the exploration, formulation, and collection parts of the ISP model. So I'm very excited about this, and I'm really looking forward to actually doing my data analysis regarding that. There is definitely carryover effects because for the way I design the process of data collection is that showing the IAPS pictures and then having a web search to be conducted and then collecting the data. I figured there's going to be carryovers. So for that, I rotated the search task. I used the Greco Latin square design, and the table that you see is a block of 3 participants, and I did this 16 times, and at the end I had 48 participants who did this block basically 16 times. So every subject that you see, they were exposed to this. For example, subject 1, they were exposed to doing the first row and etc. And this continued for 48 participants. And here's a quick review about the process. There were some interview questions involved. The participants for the second step number 2, they took the SAM self-report. They saw the IAPS pictures, whether they were neutral, pleasant, or unpleasant, depending on the rotation. Then they did another SAM self-report. They conducted the web search. The EEG at the same time was recording their brain signals, and then they did another SAM towards the end. And I pretty much repeated this 3 times because I had 3 different web search tasks for each participant. Now, when it comes to the EEG data analysis, it's very interesting because there's some data analysis software out there. They're open source, EEG Lab, for example, that I'm using, as well as MATLAB. But the process of actually doing the data analysis is pretty cumbersome. You need to filter things out. You need to make sure that you delete all the noise. And if you're not really familiar with how the noise would look like, you might get the bad data. So it is very cumbersome, although it's exciting, but there's a lot to be done, and that's why I just put it out here. If you guys have any questions, please feel free to ask me afterwards. And in regards to actually recognizing the dimensions of emotions, the few studies that have been done indicate that, for example, if you want to measure valence type of dimensions of emotion, you need to look at the alpha waves, whereas where you want to look at the arousal, you need to look at the ratio between beta and alpha waves, all of which are more concentrated and focused on the frontal lobes, and that is where a lot of cognitive processes are happening. So that's what I'm also that's what I'm also focusing on for the purpose of this study. And to also just give you a view here, what I mean by the frontal lobe, if you look at the fourth row where you see um, from the left F9, F7, F5, F3, etc. Basically, F indicates the frontal lobe, and that is where a lot of these activities are happening. And for the purpose of this study, that's also where I am focusing the most. Definitely challenges and limitations for this study. When it comes to affective neurosearch, there is a complexity in terms of collecting the data. Essentially, if you think about it, anything that we do elicits brain activities and brain signals and brain electricity, if you will. So I really had to be careful with my participants, not having them move too much. For example, even if you move your tongue, you're actually eliciting brain activities. So I had to be very careful about that. So obviously these are the challenges and limitations. EEG devices that are in the market today, they're not able to fully suppress these noises. So as a researcher, you do need to get rid of a lot of these noises. Having said that, you can do your best, but you're never too sure about that. Challenges and limitation, as you guys all know, definitely exists within any type of research techniques that you have or that you will use, and this is for the purpose of this study. This is one of them for myself. Now let's move on to the second part of the study, and this is where I am proposing a few ideas to the industries, to the designers and architects, and here's where I'm trying to basically go from a theoretical research and make it more practical, if you will. Having said that, this is definitely a work in progress. A lot of them are still at a proposal level, and I am suggesting this to be more practical in the industry, if you will. The if you think about it, a problem statement that you might think about is that when it comes to, for example, if you think about the artificial neural networks that exist today, if you start reading about those research and those engineers and architects who are actually going about creating these artificial networks, you very shortly realize that the uh, data input that they have, they're a lot digital data input, and they although they all talk about theoretically that, oh, okay, we're actually creating artificial neural networks and we want to mimic how the brain works, but they fail to look at the brain holistically. One of the data points that I've been talking about is this different dimensions of emotion of the human brain, and in none of these papers and none of these endeavors and none of the industry um, projects that you see, do they talk about this component. And the way I see it, definitely a big part of the human brain is missing um, from this equation, and this is a problem. This is something that we need to think about. So my proposal is that we do need to add one additional data input to these architectures of artificial neural networks, just so that we're able to um, mimic the brain more holistically and more realistically. Otherwise, we're just looking at it from the digital data input perspective. The reason it's important to ponder about these things is that whether we like it or not, we live in an era where brain control devices are becoming more and more advanced and becoming part of our lives. Whether we like it or not, this is a era where the physical connection and collaboration between the human brain and the physical devices are evolving. This picture, for example, although pretty funny, and I'm sure the gear that he's wearing is really doesn't mean anything, at least at this point, it definitely, to me, it's a great visual about how our lives will eventually look like, because we are entering an era where there's a lot of connection between human brain and human physics or physiological responses with these wearable computings. And I'm sure you guys also heard of a lot of this amazing technology, for example, the robot nanny that was evolved and created in Japan, and it's actually hitting the market. Or you've also heard about German researchers looking at airplanes that could be controlled through brain waves, and of course, neurogaming, that it's really hitting the market, and they're having a lot of followers. Where although these games are still in their infancy, they're pretty boring if you compare them to the bigger type of games. They're still very fascinating, because a lot of these gamers are encouraged to actually do the game with just the control of the brain. So whether we like it or not, this is an era, and I definitely aim my research contribution to be that the human emotions and the different emotions readings should be involved in the industry. And of course, going back to my research, where it's more specifically in regards to web search, definitely this could be part of the industry design, where through wearable computing you're able to reading different dimensions of emotions. You add this additional data input, and you can have the neural networks learn and be addressing these issues more from the holistic point of view. And of course, when it comes to search, which pertains more to my dissertation, I see this dissertation add to the body of knowledge in regards to being able to reading brain waves and reading the different dimensions of emotion in order to improve search results based on the neurological feedback that the search engine receive from these wearable computings and from brain waves. In other words, these search engines become an extension of the human brain by receiving the brain waves and constantly improving themselves based on the neurological feedback that they receive from users and from these wearable computings. In other words, they learn to improve themselves. And with that, I just wanted to thank you all for listening, and please feel free to reach out to me and with any questions you might have. I'd be more than happy to have a chat with you, and would love to hear your feedback as well. Thank you very much, and have a good one. Take care.